Alrighty, in this video I'm going to teach you guys about two new rules for the derivative. They're going to be the product and the quotient rule. Now if you recall from my last videos, when we took the derivative of more than one element summed together, it was just the derivative of each summed element. So for example, let's say we had a derivative like, I don't know, x squared plus 5x plus 2. The derivative of this expression would just be the derivative of x squared plus the derivative of 5x plus the derivative of 2. Now, let me erase this. Now suppose, let's say we have something like this. Let's say we have something like f of x equals, I don't know, 6x times the natural log of x. Now you would think, oh, just like the sum rule, the derivative of this entire function would just be the derivative of 6x times the derivative of the natural log of x. This, however, is not true. This also goes for functions that you divide by each other. So let's say we have f of x equals, let's just kind of do the same thing, 6x divided by the natural log of x. The derivative of this is not derivative of 6x divided by derivative of natural log of x. There are two separate rules for this, which I'm going to show you in this video. Okay, for any function that we use the product rule for, let's use some expression f of x, marker, f of x equals two functions. So let's go ahead and say, like, I have a function f and a function g. So function f multiplied by a function g. Whenever you have something in this form, the derivative of this function, f prime of x is going to be equal to f prime g plus f g prime. This right here is noted as the product rule. And you may say, well, what are these f primes and g primes in this function? Well, we're going to do a couple examples to show you what that actually means. But first, I'm going to fully define not only the product rule, but also the quotient rule. So now, let's say we have two functions, f and g again, but this time instead of being multiplied by each other, we're going to say f of x equals f prime, or I'm sorry, just f divided by g. Then, in order, the derivative of this function, f prime of x, is really equal to f prime g minus f g prime all over g squared. And we denote this as the quotient rule. We call this set here the quotient rule. So we now have this, and I'm going to go ahead and write the product rule up here as well, so that you have both of those right next to each other. And I'm going to use a black marker this time. So we have for two functions that are multiplied by each other, f prime of x is really equal to f prime g plus f g prime, and we call this the product rule. So we have both of these rules up here, and if you get confused on which one to use, it's kind of in the name. The product rule, when you have two functions that are product or multiplied times each other, you use the product rule. When you have two functions that are divided by each other, you use the quotient rule, or kind of a divided by quotient rule here. So we have these two definitions, and let's do a couple examples so we can kind of get this solidified in our head. So for our first example, let's say there we go, f of x equals 5x times the natural log of x. And we want to find f prime of x, or the derivative. Now the first thing you do is you look at this function and you go, okay, what do I notice? Well, I notice that this function is two other functions multiplied by each other, the function 5x and natural log of x. So therefore, I automatically think I'm going to have to use the product rule. So you write out, okay, I now have to use the product rule, and the product rule states that f prime of x is equal to f prime g plus f g prime. So we look at this function, and if we can find out what an f is and what a g is, then we can solve for this derivative. So usually you could choose any function you want, like when you start f5x or natural log of x. I always like to choose the first function I see as the f. So we go ahead and we label 5x as f, and we label natural log of x as g. So then once you do that, you can kind of write yourself a little table down here. You can say f equals 5x and g equals natural log of x. Now, we need f prime and g prime. So hopefully for my last videos you memorized the tables a little bit, but we can look here and we can say, okay, the derivative of 5x is simply just 5. So we know that f prime, which is the derivative of f, is equal to 5. And we know that g prime, which is the derivative of natural log of x, is just simply 1 over x. Now that we have all these variables, we can plug them back into our equation. So now we know that f prime of x is equal to f prime, which we have as 5, so put that here, equals 5 times g, which is the natural log of x, plus f, which we have as 5x, times g prime, which is 1 over x. So we do times 1 over x. And if we want to simplify this just a little bit, these x's right here, when you multiply 5x by 1 over x, you just end up with 5. So our final answer is f prime of x equals 5 times the natural log of x plus 5. Notice this was a very, very, very simple process. All you did was you defined two variables, f and g. You took the derivatives of these two variables, f prime and g prime, and once you did that, you just substituted everything back into the formula. Now for this particular example, it's very easy. There's some examples that it gets very long, and we'll go through a couple of examples, not only in this video, but in my next video. Okay, so let's do an example now of the quotient rule. So let's say, so I'm going to erase all this here. Thank you, Lordy. Alright, so let's say we now have some kind of function y equals, I'm sorry, we're going to do f of x notation. F of x equals x cubed plus x squared plus x, all divided by the natural log of x. So the first thing we do when we look at this function is we notice, okay, I see that it's a sum of terms divided by a natural log. So if you count this as one whole piece, we have something divided by something else. So now we know, okay, I have to use the quotient rule. If we recall, the quotient rule for anything like this is equal to f prime g minus f g prime all over g squared. Now, all we have to do, same thing as with the product rule, we have to determine, okay, what is f, what is g prime, and then in this new term here, we have to determine what g squared is. So, like I said, I always label the first function as f, so the top function I label as f, and the bottom function I label as g. We make our little table down here. We say f is equal to x cubed plus x squared plus x, and we say g is equal to natural log of x So now we take the derivative of f. If you remember from my last video, when you have the derivative of exponents, you just multiply the exponent out and subtract 1 from the exponent. So the derivative of f is equal to 3x squared plus 2x plus 1. And the derivative of natural log of x, which you already determined in the last problem, is equal to 1 over x. Okay, so now we have left is this g squared term. So we have g squared is equal to, if we know g is natural log of x, it's just equal to the natural log of x squared. Now we have every element we need to solve for this, so I just plug everything back in. So I'm going to move up here for this. We're going to have the derivative f prime of x is equal to, and if we look here, f prime, which we said was 3x squared plus 2x, f prime g, and g was just natural log of x, 2x, I'm sorry, plus 1, and then we said times 2x, I'm sorry, times natural log of x, f prime g, minus f, and we have f is x cubed plus x squared plus x, make sure you keep these in parentheses, times g prime, which is just 1 over x, so I'm just going to divide that all by x, that's 1 over x, and then all of this divided by g squared. So g squared we said was natural log of x squared, so all that divided by natural log of x squared. Now this is officially our answer. Sometimes your professor or instructor may want you to simplify it even more, but you can simplify it through simple algebraic techniques like, I don't know, you could, like when you subtract this, I'm sorry, this x should just be over this here. There we go. So when you simplify this, you could, I don't know, take out an x from this equation, you know, and then divide by x here to simplify this out, and then see if you can find any common terms between this and this. Sometimes professors want you to do that. Other times they just want to see that you know the concept. So this is the basic concept. This answer in its most general form is correct. Your instructor will usually let you know if they want you to simplify it to the simplest terms, but if they just say find the derivative, this would be a perfect answer. Okay. So there you have it. There's the product rule and the quotient rule. In my next video, I will be doing 4 more examples of this because I know a lot of times, even when I was learning this, I always wanted more examples. So in my next video, I will do 4 more examples ranging from very easy, like these are pretty easy, to an extremely hard one that'll take a long time. Thank you for watching.